And let's add the constraints. Can disable that. All right, so the frag test, and let me show you the contest, so constraints. And why I want to show you something, because we need to understand which type of constraints we want to add. And I want to show you in a simple example, because we will go into dynamic delay in the next week. So it's a little bit hard to explain without dynamic. So we will create a small simple asset, and I will show you how those constraints should work. So let's begin with a simple box. There we go. Let's make it a little bit bigger and thinner. So it's like a plane created from metal. And let's create, I don't know, the Rbd material fracture. Just to create a few fragments. Oh, canceling. I don't know why I press canceling. Because if you press cancel, it won't create it. Okay, let's sketch some points. Can sketch it on the surface because it's pretty flat, but I don't know, like 10 points. And we'll relax, set the input points, just one level. Input points, let's look at this. Hope it won't take too much. Okay, let's add some edge details just to make a noise. Maybe a little bit bigger height and a noise element size. Even more, 1. Yeah, this looks fine. So this is going to be like a fracture 1 or level 1. Then I go to Rbd material fractures for the second level. So if I press shift button, it should connect all those 3 guys. And I want to break those big fragments into the smaller fragments. And I will explain you the reason why I'm doing it. Come on. Let's set like 20. And I want to set fracture per piece. Okay, so now I want to take this fragment, and separate into, like, I don't know, the 20 extra fragments. So why I'm doing it, let's go here and I want to explain. We have a big fragment, so let's imagine that this fragment of a ship we did just now. Okay, and if you want to create some kind of deforming, we need to take this fragment, and doing our simulation, we need to like creating some kind of bending. Okay, so the edge can't like make a bend, but if we take all this fragment into the simulation, it will convert this element into a collision geometry. And collision geometry is like a solid object. It can't be bended or can't be deformed. So what we can do is take our geometry, take our big fragments and separate them into the smaller ones. So create a big amount of small fragments for each element over here. And how we can use those small fragments? We can use them very simply. We can create constraints between our small fragments, like a connection. And they won't be breakable, so we can break those connections. We can just link those fragments. And then if this fragment will hit something or some object will hit this element, those fragments will move. They can rotate, they can move into different directions, but they will still be connected inside of one fragment. And then using the different nodes, we can use like a Rbd Deform pieces node, we can take our fragments movement and send it like a deformation for the main fragment. All right, so now let's test it. Let's maybe more elements. Let's set more elements, and I don't want to use the noise because you can see that it's like an irregular position. So I want to set none, and we have a big amount of more or less small pieces for each huge fragment. All right, if we go to information, we have concrete fracture 1, concrete fracture 1, and that's how we can use. Let's set a different name. This is concrete. Let's say it fracture 1, and this should be fracture 2. Okay, just to make different IDs for fragments to understand what is the first level and what is another level. Now there is a bunch of nodes which can help us to work with RBDs, and you can see that there is a lot of different nodes. If you type RBDs, there is bullet sorval, the cluster, configure, connected faces, constraints, different types from curves, from lines, from rules. We can set up the constraint properties. We can convert constraint. We can deform pieces, which we will use. We can also explode or use an exploded view. Also, we can use it a little bit later. We can pack and many different stuff with the RBDs. And in this situation, I want to set the properties for our constraints. So as you know, by default, we have a constraints created by the Rbd material fracture. So we have a constraints, and if we go to the null object, oops, sorry, just sometimes tab, it doesn't work. If we connect this null, we can see that we have a constraints. We have information, all right? We have the proxies, we have the full res geometry, and also we have a constraints. So let's connect the Rbd constraints properties here. Oops. Just make sure that you connect correctly. And now here we have like a constraint group is concrete fracture 1 and concrete fracture 2. So with the concrete fracture 1 is constraints between the big fragments, like those constraints. They look not looking like this, they looks like here because we create constraints between the fragments points. If we go here to the setup constraints, and if you want to look at them, you saw they created from one fragment to another. Again, let's me show you. From the middle of the fragment, you can see they connected. This is our fragments, and if you press template, select template, you can see that we connect the middle of each fragments with the constraint. All right, so let's go here, and the first constraint type, you can see those lines here. It's a glue constraint, and let's colorize them, make them, I don't know, maybe red. Now you can see how they look. They connect. It's like, I don't know, like lines between the big fragments. So we can leave this by default. Let's call this constraint first level. And again, Rbd constraint properties. Connect this guy, and that should be constraint second level, or can name them inside constraint because they inside of each fragment separately. So now let's colorize them like, I don't know, like green. So now I can see that those constraints exist just inside of each fragment. They can't connect fragments between themselves. So now we have the same setup for this and for this. So let's keep it glue for a moment. So we're gonna keep a glue constraint. But for the second, I want to leave the glue constraint like a first constraint, but we have also a nice switch, which called switch constraint type when broken. So in fact, we can create two different constraint types depending on the rule. So if we break or broke our glue constraint, except of this glue, we will set the soft constraint, and this is by default. And the soft constraint is a very nice type. It's a new one because in the earlier versions of Houdini we had a different types constraint we can use for the same kind of result to create some kind of bending, because the different constraint type use a different different movement. They can use a position or rotation. Some can just use in position, some can use in end position and rotation, like a soft, for example. So let's imagine that we set a default settings for the constraint first level and another one level. So what we need to do now, this this constraint, now we need to set up our simulation. I will use just a standard Rbd bullet solver. It's just for example. We will talk a little bit more closely to the dynamic simulation in the next week, but for this moment let's set this element for my bullet solver. And yeah, you can see that is like main geometry, constraints, and the proxy geometry. So there is 5 inputs. And what else I want to do? I want to set the bound geometry, because if I launch simulation from this moment, let's select the bullet solver and I press play, you can see that my geometry just fall down because there is no ground, no nothing, but we have a gravity by default. Yes, with the forces we have a gravity enable, and there is a lot of parameters. We're going to talk a little bit about those parameters in next week, but I want to keep this geometry at the same position. So I want to create like a bound geometry. So how can I do this? We have a collision geometry, we have a guide sim. I will explain the guide sim the next week, but to have a nice setting for the geometry objects, we have a very good node called Rbd Configure. And the Rbd Configure is, again, like a node where we can set up many different properties for our Rbd objects. So actually, the Rbd constraint properties in Rbd Configure is like an asset, allow us to apply many different options for the objects, for our Rbd objects. In earliest version of Houdini, we do this all manually. So we set the active object. Is this object is active or not? Is it animated or not? So we can do this manually. Also, we can set up our constraints manually, set the name. Also, we can set the type of constraint, and all the things we can do manually using the attribute wrangle or different or other different nodes. But now it's like all in one node. The constraint properties, you can set any property of each of those constraints, the strengths and the half-life, the propagation rate, and all the things you can set over here, and you don't need to dive inside of the Rbd bullet solver and make change in there. So you can set up constraints before they goes inside of the Rbd. So do the same stuff here, connect the Rbd configure. You can see that we can simply drag this node into the connections. And what I can do here, well, in fact, the main type for those objects here is ability to connect the bound geometry. So here, what I can select, what I can do here, I don't know, visualization can set to active. Anyway, can leave it as concrete, can set to metal, it doesn't matter at the moment. But what I want to do, I want to create the bounding geometry. And how I can do this, I can select my box. With the transformation, I want to set the bigger scale. So let's look at my box original. Let's disable template. So here's my box. Let's make it a bit wider, and let's select primitives here and here, holding the shift button, press delete. So I'm going to use a blast node, and using the poly extrude, I want to make the distance something like this, minus, I don't know, 0.5. Cool. That's kind of our geometry, our bounce, static bounce geometry connected here. And what does it mean? It means that all now geometry is connected with those bounds. They will stick and will not fall down. Let's just check it. Is it works? Let's play. Oh, come on. Negative 0. Stick it here. And we need to use bounds. Now we can see that if we visualize the active elements, they active, but they hold with the bounds. Okay. If we go to our constraint 1 level, let's say strength, let's decrease it to 10. Still the same position. And they keep together for now, but let's hit this object with something. So that is sphere, maybe a polygon. Let's move the sphere up. Okay, there's somewhere in the middle. And what I want to do, I want to set the velocity for the sphere. So let's set that velocity. It will be or let's set a velocity from here. So minus 10, 0. Now it should move down here. Okay, and we can set the Rbd configure for the sphere also. Let's connect these guys. It will be active and connect it to the force input collision geometry. It should look like a blue color. And let's play it. Bam. But it doesn't work for our constraints. So let's set a glue constraint here like to 10 also. So we need to break those elements. Come on, let's back it here. Here you go. Bam, nothing here. So let's go to configure and set the active to 0. And now bam. Now the sphere is break our geometry. So now you can see that our red connections is too weak in this case, so we can back a little bit of strength to the glue constraints, like to 100, to make them more stronger. Something like that. Or we can switch this constraint to the soft and make a stiffness a little bit bigger, just to 20 again. Bam. Just select Rbd. So now we can see it's creating like a net. It's bouncing. So there's no, in fact, breaking. So the red one is still connected. Let's leave it 20 maybe. Increase a little bit of damping ratio. But for those constraints, I want to set this, I can set the strength even bigger. But also what I can do at this moment is try to create a proper movement. So you can see those fragments are almost all horizontal, but I want to create some kind of angle between those fragments. So how we can do this? Let's go to constraints over there. So we have a glue, have a soft, and in the soft settings we have some stuff can allow us to use the angular stiffness. So the stiffness here is the interesting parameter which can specify the strength of the force that attempts to match the transforms of the two anchors. So let's increase the stiffness to like 100. I want to enable the angular stiffness on and damping ratio. So let's play it back again. Bam. Oh, it doesn't break. Oh, okay. I don't know why it doesn't break, because if you go to the advanced, to constraint setup in our Rbd bullet solver, what we should add here is the breaking threshold. So let's select the concrete fracture 1 because I want to break those constraints. Let's decrease the distance threshold maybe to 0.1. Now select again. Bam. So somehow we can see that it's begin to move even before the sphere is going here. So maybe increase the stiffness even more, maybe to 35. And the strength for the glue maybe to 100. Okay. So it will keep those fragments together before the sphere is hit those elements. Bam. Maybe it's too much, I don't know. So let's back to constraints. Glue 100, and this constraint is 35 is a soft. I don't know, maybe let's back to 20. Maybe it should be enough. What else we can set here? So the soft constraint have the big amount of different parameters. So if let's leave the stiffness 100 by now. We can play with this a little bit later. We also have a damping ratio for angular. So a separate damping ratio value for the angular component of the constraint. So let's increase the damping. And the angular stiffness, well, actually, let's increase the ratio to like 10. Maybe it should work. And the enable angular plasticity. And plasticity is very powerful stuff for working with metal. So let's increase the angular rate. I don't know, like a 50 by 5. And let's play it again. Let me look at the sphere also. So now you can see that it creates some kind of bending and plasticity. Let's add the ground plane. Ground plane. Just move it like -3. Bam. So the sphere has a low weight, maybe. Need to increase it. Anyway, we have a geometry with some bending. Let's play a little bit with those settings. Maybe increase the damping ratio even more, and maybe the damping ratio for the stiffness, not an angular, but also the basic stiffness. I want to, yeah, you can see the nice bending, like bam. Let's increase the amount of geometry, the amount of fragments. Maybe let's set no 50. Okay. And let's hit it. Bam. Yeah, it's looking interesting. So let's create the Rbd Deform pieces node. And what I want to use my fragments from the first level, those guys, but they don't have enough polygons for bending, because we can't bend or deform polygon. We need to divide this big polygon into the smaller ones. So divide, take those guys, and they need a convex polygon, breaker polygon, maybe like set 0.1. Can do this, and let's connect our required geometry here. our constraints from here and our deform pieces element from here. So that should work. And now let's set up let's leave the cluster attribute, but for the cluster we have a name. I need to match the name. So now it should work. Let's look at this. I'm gonna keep the default settings. And let's play it. Take some time for calculation. I don't know why it's such slow. And maybe should decrease the radius a little bit. I don't know why it's such a slow. Go to our theme. Let's hit this element and let's deform this element. Okay, so let's increase the radius to like 2. That should work. Why I don't want to use a name or what? I have a name. I have a name attribute, right? And that should work for me. And I get that the main reason because the name doesn't match, because it changed the name after the Rbd material fracture one. We have the name this, and from here, if we connect, have the name different. Have level piece 001. So it's a different name, so that's why it can't connect the Rbd Deform pieces. So okay, let me store this name, but before I do this, I want just to make a little bit different geometry to show you the better like a way to look at the bending of the geometry. To do this, let's create the point in the middle of the box. So what we can do is go to transform and scale this box to 0, 0, 0. Have just 2 points, make a fuse. Keep I don't want to remove repeated vertices, so we have just 1 point in the middle. And I'm gonna use this point for Rbd material fracture, but I'm gonna create the class and input points don't need to scatter. So let's look at this. Where is my glass? Okay, so now go to cracks. Let's decrease the number of cracks to 10. Let's increase the minimum width to 1. I don't want to have a small chunks. Yeah, so back to this, maybe like 6. And with the detail amount, maybe detail size is 0.1, so increase it maybe 0.25. And the noise frequency, maybe 111. Maybe it should be a little bit better. Okay, so let's imagine that this is like a metal. And let's look at the name right now. Oh, I guess that now this name can match. I just call this thing level 101 just to see the name better. So go to Rbd Deform. Let's take some time for fill the holes and all this stuff. So I just work with the Rbd bullet solver and then transfer this information to the deforming. So I don't know why I can't see the red constraints. Oh, this now have the name level 01. Okay, let's do this. Let's change the name, and here I should change the name to for breaking. No, come on, level 1, right? Okay, and bam. I don't want to break. Let's make stiffness like 10. And it should be soft and hard. Delete constraint with the distance threshold. And bam. Now it's bending slowly. Let's increase the amount of fragments here. So let's go to primary fracture and let's set a 75 to all those guys. Maybe set cranks like 8. So we have a little bit different structure. Now maybe 7. Okay. And if we go to Rbd Deform pieces, and it doesn't work for us. Okay, let's store the name in this case. Let's then uncheck. Let's back it again to our fracture. Oh, there is no name at the moment. So if we look at here and just glass concentric, glass radial. Okay, let's leave it for a moment. Level 101. Just to make sure we create the proper result for the constraints. So let's back here. We have a constraints. And constraints level 2, that's all fine. Let me increase the angle rate to 90. That's fine. The stiffness can keep it like it is. Some maybe glue. Let's keep it glue also. Okay. So let's back to this. Bam. All right. So let's look at the names. Sorry. I want to look at the null object. Let's look at the name here. So the name is level 01 piece 000. What we have here, piece level 1 piece 0. Oh, there is 4 zeros. Okay, so what we can do is just store the name after the first fracture. So we can create I don't know, like an old name attribute, and this old name will be equal to current name, and we're gonna keep this attribute in all way here. And also we need to do the same for the proxy geometry, because we use a proxy geometry here and in output for the Rbd Deform pieces, and we should apply the old name attribute. Let me enable Rbd Deform pieces to look, is there any attribute called all name here exist? Oh yeah, and forget to switch it to the primitives because the name is in primitives. All right, let's press this button to view the list. So if you don't have, if you don't have this attribute in a list, that it doesn't go through all this setup. So now let's play it again. Bam. And our divide also connected to this attribute wrangle, so it should have the same name, and now it's working. So it's very important to deform pieces to look at the name you have here and the name you have from the first input. They should match because they look at this attribute. And now you can see a nice bending for our geometry, and it's creates some kind of a hole in a metal list. So we can use this like a bullet in a small scale, or if we have some hidden geometry to the big elements, you can do this also using this method. So definitely depending of the scale, depending of many different stuff like the speed, if we have some forces with explosions, they can also have an influence on this geometry. So what we can change here, I think it will be enough at the moment. Yeah, and what about iterations? By default, if you look at the help, if greater than 0 overrides the number of iterations performed by the constraint solver for the constraint. So we have a constraint solver inside the Rbd bullet solver. If you go to editing of content, you can see there is a lot of different nodes. Again, you can explode this stuff to better understanding how works our Rbd bullet solver. There is again many different things, many interesting things, and the main stuff is inside of the DOP network, and then we have a DOP import and caching all this thing. So inside of the DOP network we have also the bullet solver. So the bullet Rbd solver, we have the main setup here. We have the post solve, we have the pre-solve, we have the object, so we can find the pocket object, Rbd pocket object, which is connected to the first input. We have the collision objects, which this is actually our sphere, and also we have a different constraint stuff over there. So you can say constraint solver, there is a different types of constraint you can connect here. So it's like relationship geometry, DOP geometry. This is our there's no element, so this is our constraint. So it's main constraints type we connected here, and different break. There's many attributes allow us to break constraint. There's a huge VEX code. So you can dive here and look at how this thing works. So in fact, it's a very massive Rbd simulation. And again, it's look like the Rbd material fracture. We can do all this manual, but not all this. We can create our own DOP network without all this stuff if you don't want to use this. So here is constraint geometry, and you can look how our constraints transforms here and use inside of simulation. And yeah, all the stuff you can control from here. So you can see there is many different setups. So you can use a different type of constraint, the glue, soft, hard, contwist, slider, all those types. You can switch here and set any type of constraint you want or you have here. The same stuff in solver. We can see that constraint iterations at the moment have 10 iterations. So again, if you want to look where I can change this setup, or where I can look at inside of the Rbd bullet solver, you can go to more and view dependencies, and you can find where this node exists inside of the bullet solver. So we have a DOP network, and we have the bullet Rbd solver here, and we have a different setup. So you can find this constraint solver and find some settings over here. So all the thing you can do manually. So basically, before the Rbd bullet solver, we did it. So we create a DOP network, create the bullet solver, create all the stuff like gravity, Rbd pocket object, collision object, ground, different types of constraints, different types of forces we can apply to our simulation, all the thing. So now we can see that we can just apply all the stuff using the one node. So that's cool, but sometimes it's more useful to you to create all this by yourself manually. All right, so now you can see that it's working. And now our task is create two different constraint types. The one constraint type is constraints between our main fragments, and all other, the green ones, is inside of each fragment for creating the bending. All right, so let's disable that and let's create the same kind of constraints inside of our constraints geometry.